Hi class, welcome to the next builder, the event database. So where have we been and where are we going? We started by designing the user experience, making site sketches. We then tested the user experience with the usability test. We then designed the major information type. That was the event info. So that's where we were last time. Now we're going to design the database. We're going to take what we know about the event that you figured out last time and now put it into a database. Make the database, design the database that will hold the event information that we need in order to build our site. Once we've got the information in the database, we can then figure out how to get it back out of the database using queries. And finally, we can put it all together by taking information out of the database, putting it onto a web page using the queries that you'll figure out. So there it is, the whole process. And look how close we're getting to the end. You've gone through the majority, as of today, you've gone through the majority of the builders that will get you all the way from conceiving of an event site all the way through putting together the technology on a web page. Now clearly you're not able to now go get a job as a web developer, but it should give you a pretty good overview of what a web developer does and how they put it all together, from design through the implementation in a database and finally how pages are constructed. Okay, what is the point of this builder? We need to store our events somewhere. You've designed an event, now we have to figure out a place to put it, and that place is a database. What are the steps? First, you're going to model an event as a single table. That's one database table that contains all the event information. But that's not a really good way to do it. In fact, people never really make just one table to contain all the information. Usually they create a set of linked tables. And so that's what we're going to do in this module as well. We're going to create a model first that's just a single table, kind of the newbie model. Then we're going to go into a two-table model and show you how you link tables together. And then finally we'll do a three-table model so that you get some practice in linking tables together. This is what you have to do, as always. Download the template file. Go back to G-Class when we're done looking at this video and follow the directions explicitly as you see them in G-Class. There's lots of great information in there about how to do things. Don't miss out on the good instructions that are sitting there right in the G-Class file. Of course, when you're done, you'll have created a file and it's a filled-in version of the template, and you upload it back up to the server, and then we'll evaluate it. Okay, brief review about tables. We talked a little bit about this last time, and I want to go over it again. Databases have tables. And if you remember, a table looks a whole lot like Excel. There's an Excel table, sort of, with rows and columns. Each row has one item of information, and each column has one attribute of that item of information. In this case, we're looking at the position table inside of G-Class, and it doesn't really matter what's in each of those columns, but you can see that the thing has an ID, a student ID, a mod ID, module ID, date time it was begun, points possible, points gained. Those are all columns that one item of type pos student has. So tables, they're the major structure. They hold information about the type of information, and you're going to be working on an event table, and finally an event set of tables. Databases have rows and columns. Tables have rows and columns. Each row is one item, and each column is one attribute, as we talked about just now. Tables have relationships. This is where people usually start getting off the train. It's easy to see that tables have rows and columns. It's easy to see that every row is one item and every column is one attribute of that item. But now we want to get a little bit more specific. We want to get a little bit more detailed. We want to get a little bit more professional about the way that we do tables. And to do that, we're going to make relationships between tables. So you can see here a relationship between the task table in G-Class and the accomplishment table in G-Class. Each task, and that's in the first table, each task has an ID, a title, points possible, and points expected. But it also has an accomplishment ID. And notice the accomplishment ID of those vocab quiz, vocab face-off, and vocab story. They're all speakers, whereas fill-ins are all learners, and concept quiz is a thinker. So how do we relate the speaker to all three of those rows without typing the word speaker over and over again? And you may be wondering right now, well, why don't we just type the word speaker over and over again? I'll talk a little bit about that later. But for now, just get the concept. Instead of typing speaker over and over again, we type the number 3, which is the ID, the identifier for speaker in each of those rows. Now we have effectively linked the task table, and the accomplishment table. Okay, that's a hard concept, and I'll come back to it again in just a few minutes. But begin by modeling an event as a single table. So you have your event, you know what it's got in it because you figured that out last time. Now you want to create one table that models that event. There's something I want to show you, and it's the way that we've been looking at tables versus the way that we're going to start looking at tables. So we have here the kind of Excel version of a table, and in fact I just took a screenshot of Excel to show you this table. It's got rows and columns, and it's pretty easy to see what's going on, but it's also kind of bulky, and we don't really need, when we're working with the notification table, for example, we don't really need to see all the data that's in the notification table. In fact, really all we need to know is what's the name of the table and what columns does it have. And I think you'll agree that showing tables like Excel, it gets a little bit burdensome after a while. It's just there's a lot of bulk there. There's a lot of extra stuff that you don't really need to see. It's nice to look at them to see examples of what the data is like, but once you know that, you really don't need to see the data in all the rows of the table. What you really need to see is the table and all its columns. So we're going to go towards this way of looking at tables. It's a box, and the box has a title, and the title of the box is the name of the table. Then the box has a series of lines inside of it, and each one of those is a column. So you can see that a notification has an ID, a picture, text, date, and time. And in either view it has both of those things, but in the view that's a nice little box with no data in it, it's really easy to see that table, and it's going to be really easy to see how that table is related to other tables. So that's the way it's done in Lucid. So pause the video here, go and learn how to use Lucid from the instructions in G class, and make a little picture of a notification, of an event for your system that has all of your event data in it and uses only one table. And then come on back when you're done doing that. Okay, I assume you have a model of your event as a single table. Now let's talk about how you might take that same model of an event and make it into two tables. So there's a little work that I'm going to do to run up to this. Why would you need more than one table for an event? It looks to me from your work so far that that event table has everything you need in it already, but it's really not the way the professionals do it. And there's some simple reasons why professionals don't do it that way. The location, for example, that's in an event, where it is, you're going to repeat that location over and over and over again. Every time you have an event at the same location, you'll have to repeat all that data over and over again, and that's kind of messy. It leads to all sorts of problems, the least of which is that you have to type that over and over again. And the more data you have in the database, the more redundancy there is when you type the same thing over and over again. But there's really bigger reasons why we would break a table into two tables, and that's to make sure that there's no chance of typing errors. What if one time you spelled, two events happen at Seattle Center, one time you spell center correctly, the other time you spell center incorrectly? Those two events are going to seem as if they're in two different places when in fact they're not. When you have all the locations in one table broken away from the events, and then you just reference the location in the event table, then you've only typed the particulars of the event of the location one time, and you're using those particulars over and over again. Excuse me, I have to take my toy away from my dog. Penny, quit squeaking that. Okay, now here's the biggest thing, and the reason really why people do this. Okay, come on, Penny. The reason why people break tables into two is to make sure that when they change something in one piece of the database, it changes everywhere else automatically. If I have the location Seattle Center typed in 20 times into my database, and now for some reason the name of Seattle Center changes and it's now a different name, that would mean that I would have to find the 20 places where Seattle Center is typed and type them over again. Whereas if I have Seattle Center typed in one time and just referenced by an ID other places in the database, I change it one time in one place, and then boom, it's automatically different for every record, that's for every other event that's linked to Seattle Center. So that's why we do it. And these may seem like simple reasons, but they're only simple when you have a simple database. When you have a complex database, they become extremely important, and they also become the basis of how we do databases. They're called relational databases because tables are related to each other. There's really no databases anywhere in the world where things are just one big fat table. They're always broken into subtables, and it's for these reasons. And the more you do this, the more important these reasons become. All right, that's why you do it. But how do you do it? Let me go back to this idea of identifiers. How does someone identify you? They identify you by some kind of ID. Your license number or your passport number or a credit card number or a student number, those are all identifiers. And in all the databases around the world where you are, where your records are, your name isn't always in there, but your identifier always is. And the reason that your identifier has to be in there, but your name may or may not be in there, is because if I have your identifier, I can always look up your name. So that same thing I was talking about before becomes extremely important. So in your student database, or in my G-class database even, I can just have your student ID, and when I want your name, I can go look it up in some student table in some university database. Very convenient. I have one little piece of information, your ID, and that will lead me to get anything else I need to know about you. So that's how I identify you. But how do you identify anything? Think about it hard and you'll realize that any object, anything in the world that we want to identify, we identify by an ID. Look in your car. If you look in the front window of your car, you'll see a vehicle identification number. That is the unique identifier of your car. If you look on the bottom of your laptop computer, you'll see an identification number for that particular laptop that uniquely identifies it. These identifiers are everywhere. They're really important, and they're also the way that we relate Table A and Table B. So here you see in this little diagram here, we have an event table A and a set of locations in table B, an event table and a location table. How do we know that an event refers to a location? We share an ID between those two tables. We list the ID of the location in the event. IDs are key. And I use that word key, pun intended, because we call these things keys. There is a key to the location table stored in the event table. That key unlocks all the data about the location. So here we have T's and growing regions. For every growing region, there's one T that it grows. That's the way the system works. So in one place in the world, they grow a certain kind of T. But one T can grow in many different regions of the world. So we have the T, which is the ID of 3, and that's called Xinjiang Maojian. We have T that has an ID of 5, and that's Oolong T. Those are two different kinds of T's. Now we have a bunch of different regions. Some are in China, Taiwan, New Zealand, and notice that T number 5, the Oolong T, can be grown in 3 different regions. What we say is that T's and growing regions have a one-to-many relationship. One T can be grown in many regions, but every region only grows one T. Let me say that again because it's an important thing to think about, and it's an important way for you to understand how your tables are related. One T can grow in many regions. Would you agree by looking at this diagram? That's true. One T can grow in many regions, but each region only has one T. If we wanted to make it more complicated and say that any T can grow in any region and any region can grow as many T's as we want, we'd have a more complicated database. We have a relatively simple database by saying that a single T grows in many regions, but for each region there's only one T that's going to be allowed to be grown there. And that's how the link is made. See the number 5T? The number 5T is in 3 different regions. See the number 3T? The number 3T is in one region. So for each region we have a single T, but every T has some region. Okay, let's look at this from another perspective. Looking at the issue using our other way of looking at tables, where the tables are boxes that have the name of the table at the top and all the columns in the table below, we can focus in on the relationships between the tables. So for every event, and this is in your system as well as on this slide, for every event there's one location. That's a simplification. We can certainly have events that happen at multiple locations, but not in our database. We're going to keep it simple. For every event there's one location, but one location can have many events. That's reasonable. So one location can have many events. We draw a line between the location table and the event table, and notice that one side of that line is straight and the other side has some spurs coming off of it. We call it a crow foot. Kind of looks like the foot of a bird. The table that has the crow foot is the many table. One location, many events. The many events is represented by those 3 lines. The one location is represented by the one straight line. So one event, many locations, and that's what it looks like. Okay, so go ahead and make your two-table representation of an event using locations and breaking the locations out from the events, and try to create a diagram like the one I have here, but instead of all of my columns, put your columns in the diagram. And then when you're done, come back and we'll talk a little bit about modeling an event as three tables. Okay, welcome back. By now you should have a one-table version of your event and a two-table version of your event. Now you can move on to a three-table version of your event, or a four-table or a five-table or a six-table, getting more and more sophisticated with the way that you represent events. Honestly, in a real database system, an event could have 10 tables, 20 tables. It could have a lot of tables breaking out the information of event into more and more specific pieces. So what I want you to do for the three-table is break the locations out. Notice in your location table, Seattle keeps coming up over and over again. So break the locations out, following the instructions in the G class. Follow the instructions to break out a third table out of your database and represent it using Lucid, using that same crow's foot notation, with the one table having a straight line and the many table having a crow's foot attached to it. So try that, and that should give you some practice in figuring out how tables are related. Now that's just about as far as we're going to go into databases and into the relations between database tables. And so having completed that exercise, you'll be in a position to know everything that you need to know for this particular class. All right, we'll see you in the next exercise.